Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. Today we are going to talk about the process of neurulation and notogenesis. Process of neurulation, or the formation of the neural tube. At the beginning, we are going to make simple review about the stages of the development of the embryo, starting from the fertilized ovum, morula, blastula, and then the gastrula, where the transformation of the bilaminar germ disc into trilaminar germ disc, forming three germ layers: ectoderm, endoderm, and mesoderm. Here again, this is the embryo, and this is the structure. This structure is named the primitive streak, which appears at the epiblast surface at the caudal end. The appearance of this structure occurs during the third week of development, indicating the start of the process of gastrulation. It's composed of primitive groove, primitive node, and primitive pit. Now, the cells of the epiblast, which are close to the primitive streak, they start migration toward this area, and they will pass in between the epiblast and the hypoblast. Some of them displace the hypoblast cells, forming the endoderm. Some occupy this area between the epiblast and hypoblast, forming the mesoderm, which is the intra-embryonic mesoderm. Other cells remain in the epiblast, forming the ectoderm. So, at the end we have three germ layers: ectoderm, mesoderm, and endoderm, and the structure is named the gastrula. Here again, this figure shows direction of migration of cells. The cells pass from the epiblast through this groove. They take their way in the area between the epiblast and hypoblast, and they take different directions of migration. Some go laterally, some go toward the cranial end, and they will settle down in front of this structure, which is the precorder plate. Here, this is the site where they settle down in the cardiogenic area. At the end, we have three germ layers. The epiblast will form the ectoderm, hypoblast will form the endoderm, and here the mesoderm layer. At this area, we can see a structure appears, which is the notochordal process. This results from the direction of some of these cells. They take the direction pathway starting from the primitive node toward the cranial direction, forming a solid cord of cells, which is the notochord. These dotted arrows shows the direction of migration of cells. Some of them, as I mentioned, they go cranially, and they take place in front of the buccopharyngeal membrane. They settle down in the cardiogenic area. Here, some of them go laterally, as you can see in these dotted arrows. Now, the notochord development occurs when the mesenchymal cells migrate from the primitive node and to form the midline cellular cord, which is the notochord. Here, this is the primitive node, and this is the notochord process. Extend cranially from the primitive node toward the cephalic or the cranial end. This grows cranially until it reaches the precorder plate. Starting from this area, goes cranial direction until it reaches the precorder plate, which occurs at the site of the future mouth. The notochord is a cellular rod, forms the first longitudinal midline axis around which the vertebral bodies are organized. and is the basis for the axial skeleton. This is the notochord. Here again, this figure shows the notochord. This process represents the notochord. This is the primitive streak. As I mentioned, it starts from the primitive node, goes in the cranial direction, growing until it reaches the future primitive mouth. It becomes canalized, forming a hollow tube, and which is the notochordal canal. Communicate with the primitive pit, as you can see here. This is the communication with the primitive pit. This again, a figure showing this is the notochord. It represents a midline axis around which the vertebral bodies will be arranged. So we can define neurulation as the folding process in the vertebrate embryos, which includes the transformation of the neural plate into a neural tube. It's termed the neurula. Neurulation takes place in 4 stages. First, transforming of the central portion of the embryonic ectoderm into thickened neural plate. Then, this neural plate will undergo shaping and elongation. Then, bending of the neural plate around a medial groove will be followed by elevation of the lateral folds. Then these lateral folds meet together and fuse in the midline, closing the plate, change into neural tube. As you can see in this figure, this is the neural plate. This is not a cord. This is the neural plate. It will elevate at the lateral sides. These lateral sides will elevate, and this is the middle groove. Then they continue to approximate toward each other until they fuse, as you can see here. So this is the plate, which is changed into a tube. It is the neural tube. Formation of a dorsal hollow neural tube by ectodermal cells flatten into neural plate, as you see, and the center of the plate sinks, forming neural groove. Edge of the plate elevated to form neural folds. They fuse, forming a neural tube. Here, the anterior end of this tube develops into brain, whereas the caudal or the other end will form the spinal cord. Neural tube gives rise to brain and spinal cord, formed from ectoderm overlying the notochord, so extends from the caudal plate to the primitive node. It soon divides into cranial enlarged part, which forms the brain, and a caudal tubular part that form the spinal cord. This process of formation of a neural tube is named the neurulation. Here again, this is the neural plate. It will change, gives the neural groove by elevation of these both sides. They approximate toward each other, forming this groove. Then they will meet at the midline. The plate will change into the neural tube. Here again, this is the notochord. Induces this overlying ectoderm, forming the neural plate. Then this plate will change into tube. Here it is closed, forming the neural tube. These cells detach from the crest of these margins. These cells, as you can see, these cells at the crest of the elevated two borders, they are named the neural crest cells. After closure of the tube, they will detach from this area and migrate in other directions, giving different structures of the embryo. These are the neural crest cells. This is scan electron microscope showing this process of neurulation. This is the plate. As you can see, this is the groove. These are the elevated borders, and here the tube is closed, and this is the neural tube. These cells, which are neuroectodermal cells, along the crest of the neural fold, they differentiate as neural crest cells. This is the neural tube, this is the cranial end, and this is the caudal end. This is lateral view. It represents a mouse embryo about 9 days of age. These ends, one is the cranial pore, the other is the caudal pore, as you can see here. Here again, this is the tube showing the two ends, the cranial pore and the caudal pore. These will close later on. The cranial pore will close earlier, about 2 to 3 days than the caudal end. So the tube will be closed from all sides. These figures show some congenital deformities that may appear during the neurulation due to any reason. Could be different reasons may give these defects. Here, as you can see, any defect in the closure of the cranial pore give these conditions as acrania or other cases. And here, the caudal neural pore, if there is any defect during its closure, may cause these deformities. This figure again shows this is the notochord, and this is the neural plate. As you can see, the intraembryonic mesoderm, this is intraembryonic mesoderm. It will be divided into 3 parts on both sides of the notochord. Here, this one side, this is the other side. The intraembryonic mesoderm is divided into paraxial mesoderm, intermediate mesoderm, and lateral plate mesoderm. The paraxial mesoderm on both sides, they will give somites. These are the somites, about 42 to 44 pairs, because they lie on both sides of the notochord. And this is the intermediate mesoderm. The lateral mesoderm is divided into somatic part, and here you can see splanchic part, somatop. And this is the other one. This is close to the endoderm. This lies close to the ectoderm. Thank you for your listening.